So for our introduction here, just a few things. I have this slide up here with some statistics. And you can read it if you'd like there, but basically the two big takeaways that I take from this is that bullet up near the top there where it says 75% of all hacks are at the web app level. So in other words, what it's saying is the vast majority of incidents that we see in the news, whether it be government or military or private industry or whatever, tend to happen just using very basic, simple tools pointed at the web application. So something just like a web browser, Google, whatever, tends to lead to the vast majority of vulnerabilities. I was looking at something just the other week where there was a story that came out that there was potentially, possibly some vulnerabilities with the way some of the software systems are set up in Boeing's 787 Dreamliner. And it turns out that the security researcher that got his hands on some confidential documentation about how those systems work on board the aircraft, and then used those to dig into the details and see if he could figure out a theoretical way to exploit that. Well, how did he get his hands on that confidential material? Well, he opened up his web browser and he did a Google search on like 787 internal networking or something, and he's able to find the documents were exposed on one of Boeing's servers by mistake. So it happens. Anyway, the other takeaway from this, that second bullet there where it says 97% were vulnerable to attack in this particular study. It's just the way it is. And the truth of the matter is just about every web application that's out there has some sort of vulnerability to one extent or another. And most people don't realize really how secure their stuff is until you become a target. Now, you may be lucky and never become a target, or you may become a target of some automated tools or something, or you may be very unlucky and become a very high profile target, and then you really find out how good your stuff is, right? So there was several years back, there was that incident in Ferguson, Missouri with the, that involved the police and some of the actions that they took, and they ended up becoming a very high profile target. And so the IT systems of that particular county in Missouri ended up becoming targeted by groups all over the world. And it became very apparent very quickly that their stuff was not really that good. Next thing you know, there's body cam footage out on the internet and all sorts of other stuff. So, you know, and so sometimes one of the best things you can do with your web applications to find out how good your stuff is make yourself a target, right? Either you play the bad guy and you try certain things against your applications, maybe not in production, but you know, in your testing or staging environments, or potentially you pay somebody else to do that job to actually, you know, play the role of the attacker and, you know, see how your application really responds. And like they always say, sometimes, right, who's the worst person to test your application? The person who built it. Because developers have this really weird habit of tending to use the application the way it was supposed to be used. And when you're looking things like vulnerabilities or injection, things like that, usually those things come up because you use the application in a very, very unusual way that it was never intended to be used. And so if you can do that role, that's great. But if you can find somebody else that's really good at that, then that works well too. But as was mentioned kind of at the very beginning during the intro there, you see nowadays just these stories come out every day about millions of credit card numbers have been exposed, or you know, lots of email addresses have been compromised, and it just seems like it's a daily occurrence. Well, and it's just becoming more and more and more prevalent. Why? Well, that's an interesting question to ask, right? So I got a slide here that just mentions some of these sort of, we call them popularity factors, because you know, this is kind of good to be aware of sort of why this is becoming such a big, sort of gaining so much momentum. And really it comes down to the nature of modern web applications, right? So the first one there up at the top says ubiquity, lots of web applications to attack, because it seems like everybody has, you know, some web application for doing something, and it's just, so there's lots of targets available, right? Simple techniques. The thing with web applications is HTTP is a text-based protocol. So it is super easy just to basically look at the data that the web application is sending back to the server, and then potentially modify that data, forge your own data. Super, super easy, right? All you need is like a web browser and a text editor usually, okay? There's fancier tools that we can use. I'll show a couple of them, but really because it's so simple, anybody can do it, you know? Anonymity, it's not hard to basically launch, you know, attacks or test out exploits and be pretty sure that you're anonymous, right? So when you look at things like your web server logs and you see IP addresses and things in there, that doesn't really tell you a whole lot. And so you should probably just let it go and focus more on being immune from that sort of thing rather than trying to figure out, where it came from or who did it. That's just the nature of the beast, right? So two quick stories on that. One, I had a client one time that had a very, very routine SQL injection vulnerability. And it was easy to fix. So we went in there, we rewrote their database code so they didn't have that injection problem, and it was fixed. So we told the president of the company, here's what it was, here's how we fixed it, everything's fine. But then the president of the company said, well, that's nice, but I want to know who did this to us, because a bunch of data ended up in their database from injection. And I said, don't worry about it. It's probably just some automated tool out there that's running that landed on your server, tried a known exploit, it worked. It's the way it is. Okay. It's like, no, I want to know who did this. Okay. So went to the web server logs, got the IP address, reverse lookup, geographic, and so then I emailed him a Google satellite image of this like province over here in China with a circle around it, and it's like, best guess, somewhere here. Probably not, but anyway, best I can do. So then he's like, well, is there any way that we can can you attack their stuff? Can you do stuff to get back at them? It's like, no. And even if you could, no, because right now it's just some automated thing that's out there, right? And if you do something to get the attention of an actual human on the other end, you become a much more interesting target. You don't want that kind of attention. Just let it go. And then he was like, well, can we just block all IPs coming from China? You can, but that's not really going to help. But anyway, so you deal with that a little bit sometimes. And so when you're working on secure applications and something happens, or you're doing something that's going to have an effect on some other aspect of the app, sometimes your hardest job isn't fixing the problem or even finding the problem, but it's sort of explaining to others why certain things have to be done a certain way and that sort of thing. Anyway. Firewalls. So firewalls typically are not a lot of help when we're securing our web applications, because we've got to let traffic into the application, right, on port 80 or 443 or both. And so firewalls are good to have there to prevent access to maybe other ports or other things that are going on. But when it comes to the web app itself, usually the way that you get into the application is the same way you deploy exploits and things as well. Custom code. It used to be, right, that a lot of websites were just presenting data, static HTML. And you can't really do much with those. They're not very exciting, right? And then some applications had some dynamic aspects to it where you could maybe do a search or create a new record in the database. But now it seems like just about every application is code driven. Even your mom and pop e-commerce site is, ASP.NET Core with EF and all this stuff, because it's becoming easier to do that sort of stuff. So that opens up more opportunities. Immature security. So, as you probably know, technology nowadays it's always moved fast, but now it's in certain areas is moving really fast. Especially when we talk about areas like JavaScript development on the client side, like React and Angular and those sorts of spaces. They just move so fast that in order to really truly fully understand how a particular framework works, so that you can feel confident about things like security aspects, well, once you get there, the new thing comes out. So fortunately, that's just kind of what we have to deal with. Constant change. So this is one where some of the applications I work on has the ability for some employees to actually modify the site content via a content management system, something like that. So they can actually make changes to the site to take effect immediately, in real time. And so if you're in a situation like that, it becomes more challenging because you have to now ensure that your own people aren't accidentally sort of introducing vulnerabilities. So it's not just a matter of making sure that your application is secure when you deploy it, but that you have to continuously verify and check that it remains secure sort of through its lifetime and through its life cycle, right? Because it can change in ways that don't even involve deploying a new version of the app. So, and then the last one, as we can see, there's a lot of opportunities now where money, right? So if I can get, even if it's something as simple as getting your users' email addresses, that's worth something to people, right? If you can do something like get credit card numbers, well, it's potentially worth some more money. But these are just some different things that, if you look at this list, you kind of understand that, yeah, it's probably going to get worse before it gets better, right? Because it's the nature of the web. So when it comes to your web application itself, sort of then what are the areas of my web application that I need to sort of pay attention to or look at for potential vulnerabilities? Well, kind of like everywhere, right? So the first one here says web platform. So remember, when you're building a web application, there's the code that you write, but then there's a whole lot of other functionality that's provided by code that you didn't write. And so you get to decide kind of how many dependencies you take on other people's stuff, right? And it could be a case where you have dependencies on, maybe some Microsoft code that you think is probably better than yours, but in other cases, you may have dependencies on third-party components that you're not as sure about, right? How secure is that stuff? Sometimes you'll take a dependency on some other library or some, user interface thing or something, and then all of a sudden it stops being maintained because those people have moved on to something else or whatever. Now security vulnerabilities get discovered and there's nobody there to fix them, but you're using that stuff in your application. So we'll talk a little bit more about that and dependencies, but just even if you try to write all the code yourself, you're still dependent upon the web server, the operating system that you're running on, and whatever development framework you're using, ASP.NET, Java Server Pages, whatever it is. Then of course there's the application itself. So, your logic, your code, management interfaces are a classic one, right? Once you start having an area in your site where people have the ability to do, privileged operations, then that's something we had to pay special attention to, right? The database. So a lot of times now web applications talk to a database. So if I can just get around your web application and talk directly to your database, or at least use your application as kind of a pass through to the database, well then that's gold, because really most of the time, one of my high value targets is your data, right? Whatever it happens to be, or at least the data that you're responsible for hosting. The web client. So it may be the case that I'm not really interested in your data, but what I am interested in is your users. So in other words, I want to get at your users or some information that belongs to your users or something like this. And so some of the attacks that we're going to talk about involve figuring out a way to get my content delivered to your users by you. Because the thing is, I can create a website that does all sorts of evil, nasty things, but now convincing one of your users to come to my website, sometimes not as easy. But if I can have your site deliver my content to your users, that's much nicer because your users trust you. They don't trust me. So that can be of value too. So the attack isn't really against you, it's against your users, and they're using you as sort of a go-between, right? Which still makes you look bad because if something bad happens to your users, the stuff came from you. It's hard to explain that to the users sometimes. Transport. So I may not be interested in sort of really attacking or penetrating your application, but I may just be interested in seeing what kind of information flows between you and your users, or you and your partner companies, or whatever it happens to be. So eavesdropping, basically, right? That may involve actually listening on the wire, or it may involve listening to stuff that's in the clear on intermediaries, we call it, because it may be encrypted between point A and point B, and then encrypted again from point B to point C, but it's available to be seen while it's on sort of that midpoint. Yeah, how about that? Cool. All right. So, and the last one there is one that we aren't going to talk too much about, but I may mention one or two things, which is denial of service. So this is one of those cases where I may not be able to steal your data or affect your users, but if I can't, get what I want, I'll just make sure nobody can, and just make your application unavailable to your users. There's a few simple things we can do to help with that, but sometimes this can be a little bit tricky. So you can argue whether that really falls under security or not, but it would be nice if we can maybe do a couple little things to sort of make that harder for people to do that kind of thing. Okay, so yeah, weak spots. Cool. Okay, so what I want to throw out now, and so we looked at kind of, what makes it popular for people to do, these kinds of things. What are some areas in our application, in our stack, that potentially are things we need to pay attention to, or weak spots? So what about the actual issues themselves, the actual security vulnerabilities or exploits? Well, there's a pretty well-known list that's out there. It's made available by an organization called the Open Web Application Security Project. So they publish something called their top 10 list. Okay, we have folks in here that have heard of this before, the OWASP top 10. Okay, Yeah, same as the morning. We get a handful of nodding heads. Okay, because yeah, I do come across, usually about half the room typically has heard of this before. And so, yeah, what they do is they just basically talk to security professionals and app developers and try to get a consensus about kind of, all right, what are the sort of the most popular or most prevalent security issues that folks are dealing with nowadays? And they update this list every couple years, okay? And I will tell you this. If you can look at one of your web applications and you can sort of work your way down the OWASP top 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that may take some time, but if you can get to the end of that and be able to say with, a pretty good degree of confidence that I don't think my web application is susceptible to any of these top 10. If you can do that, you'll probably be in the top 1% of all sites on the web, right? I mean, is there more to look at? Sure. Just because you're immune from these top 10, does that mean you're good to go? No, there could be other things to look at, this and that, but it's a really good sort of starting point, a good jumping off point to then explore sort of further. And some of these, are really hard to be able to say with a high degree of certainty that you're good to go, but it does serve as a really good, like I said, good starting point. So what does it look like? Well, here's our current top 10 list. It says 2017, but this is the most current list because like I said, they only revise this every few years. So we will actually end up touching on all 10 of these by the end of tomorrow, okay? Some of these there's very little to say about just because there's not much to say. Other ones will just give you sort of an idea what it's about, and then there's a few of these that we'll dive into more details on, okay? So number one, which has been number one for a really long time, I think ever since they started this list, injection. So that's the section we're actually gonna cover next. Well, we're gonna do some profiling stuff and then we'll get to injection, but we'll talk about that one quite a bit. 2, broken authentication. 3, sensitive data exposure. 4, XML external entities. We'll mention what that's about. Broken access control, security misconfiguration, cross-site scripting we'll talk quite a bit about. Insecure deserialization, using components with known vulnerabilities. Sometimes people read that one and they're like, why would anybody use a component with a known vulnerability? Well, you're just using something that's been around for a little while. There are vulnerabilities that have been discovered that are known by some people, but just maybe not, you're not aware of it, okay? Really number 9 could be sort of rewritten to be, using old stuff that has something known about it, yeah. Insufficient logging and monitoring, and so we'll mention that one too. So, and this list changes a little bit from revision to revision, but there's a few of those that are sort of always there. They just kind of move up and down, but there's another thing that OWASP makes available, which is really interesting and cool, which is something called the WebGoat project. And what this is the OWASP folks have made a web application which is intentionally built to have a lot of these vulnerabilities in it, okay? I think all of them actually. And so what you can do is you can actually download this thing, you can run it on your own machine, or you can like put it on a hosted instance out on the cloud or something, and then it gives you something that you can just play with and try these things out, right? So some people are interested just in, okay, how do I make sure I don't have SQL injection? Other people are interested in, I want to actually do it, right? I want to get a form and I want to type some stuff in there to make bad stuff happen, because that can be fun, and you can learn something about how things work. So the WebGoat project is a cool one, and so what I've done is I have created an instance out on the web specifically for this training, and I provided a link to it in the GitHub. Now, unfortunately, I do have to say a couple things about this. So on my machine here, I can click it and I can bring it up, and there's a login page here. It says username, password, but then there's a register new user link. And if I click that, you can just create a new account, any username, any password you want, and then you'll be able to, you can get into the application. Now, let me just say a couple more things about this. So once you're able to get into the application, there's a list down the left side of all sorts of different categories of vulnerabilities. And then there's also some good information about here. So for example, if I click on injection, SQL injection, it kind of talks about what SQL injection is and gives some examples here. And then it says, hey, it's your turn, give it a try, right? And there's all sorts of interesting, cool ones in here, as well as cross-site scripting and access control flaws and request forgeries and even some challenges down here at the bottom and stuff. Now, ran into a bit of an issue here because this morning, when there were a couple in here that we wanted to kind of try out sort of live and for real, when I went to do the SQL injection, there are some components on your guys' network that sort of scan for some certain things. And so when it saw some of the stuff I was trying to submit, it went ahead and just blocked that and returned a service unavailable error. So, but you have the link in the GitHub to this. And so what I would encourage you to do is at some point after the training, you know, at home or wherever, if you can get on a network that's a little more open, go here and feel free to try stuff out and do stuff, right? But there are others that are out there too. And so another one that's somewhat well known is if you just go to hack.me, this is a place where you can create a free account and you can see the community can build, host, and share vulnerable web application code for educational and research purposes. It aims to be the largest collection of runnable, vulnerable web applications, code samples, and CMSs online. This is cool because not only can you try things out, but you can also post your own. So if you think you come up with something that's really cool, you post it up there, other people try to like, you know, attack it or whatever, and then they can give you feedback and everything, and it's kind of cool. Here there'll be examples that are done in .NET and Java, all sorts of different things. So yeah, there's some cool stuff there. So you can feel free to explore and whatever, start a HackMe, upload, create your own. And there's many other ones out there, but HackMe and WebGoat tend to be two that are pretty well known. And again, for the WebGoat one too, it's available as a Docker container, so you can actually just run it on any machine and be able to play around with it and do things. Or, you know, it can be educational too to try to just build your own vulnerable web application, intentionally vulnerable, and then do stuff to it. And, yeah, have fun with it, right? All right, I'll show you some more resources a little bit later tomorrow. So unfortunately, what this means is some of the stuff that I was hoping to maybe get you guys to try out and do sort of in the room here aren't going to work so well, but I'm going to leave the WebGoat thing up and the GitHub up for probably a few weeks. So if you can find the time to go in there and play around a little bit, that might be a good experience for you.